Hello everyone, in this question I'm going to show you my solution method to solve this question. First of all, at first glance you can think that substituting 0 or 1 instead of x may be the solution of this equation. So let me substitute 0, let's say. 6 to the 0 will be 3 to the 0 minus 2 to the 0, and it will be 1 equals to 1 minus 1, and which is not valid, or which is not true. If I substitute 1, 6 to the 1, 3 square minus 2 square, and it will be 6 equals to 9 minus 4, it will be 5. Again, this equation is not valid. Therefore, you can see that x must lie between 1 and 2, and it must be an irrational number. So let me investigate this question in another way. I can see that this expression is the square of 3 to the x, and this is the square of 2 to the x. And this expression can be divided or can be written as or in terms of these two expressions. Therefore, let me write that 6 to the x will be 2 to the x multiplied by 3 to the x equals to 3 to the x square minus 2 to the x square. And if I rewrite this quadratic equation, let me rename 3 to the x as a and 2 to the x as b. Therefore, if I substitute these new variables, my quadratic equation will be a times b equals to a square minus b square. Let me again reorganize it. A square minus ab minus b square will be 0. This equation tells me that if I can find a relationship between a and b, I'm going to find the solution to the question. So I think that, at least I hope that, most of you know how you can solve such quadratic equations. Let's say I have a quadratic equation in the form of ax squared plus bx plus c equals to 0. By using discriminant analysis, you can solve this or find the roots of such a quadratic equation. And in order to do that, the discriminant can be written as b squared minus 4 times a times c, and the roots will be x1, 2 will be minus b plus minus square root of discriminant divided by 2a. So this information is important to find a relationship between a and b in our next step. So when I have looked at the b of the equation here, it is minus 1, and minus 1 square will be 1. 4 times the constant of the first term is 1, and constant of the third term is minus 1. Therefore, the discriminant will be 1 plus 4, and it will be 5. And I'm going to directly write the relationship between a and b. A minus of the middle term will be plus 1 plus square root of discriminant, which is 5, 2a. It is 2 multiplied by b, and a minus 1 minus square root of 5 divided by 2 multiplied by b will be equal to 0. So this expansion shows me that a and b are related by 1 plus minus square root of 5 divided by 2. So let me investigate the second equation. Let's assume that a divided b equals to 1 minus square root of 5 divided by 2. And I already know that a and b is 3 to the x and 2 to the x. Therefore, 3 divided by 2 to the x will be 1 minus square root of 5 divided by 2. So I'm going to show you that this is a positive number. And if you take the exponent of a positive number, you cannot obtain a negative one. However, when I have looked at the right hand side of the equation, this number will be a negative one. Therefore, this equation cannot be considered. Therefore, I'm going to look at the first equation, the first expression for the solution of the question, this one. This means that a divided by b will be 1 plus square root of 5 divided by 2. It means that 3 divided by 2 to the x will be 1 plus square root of 5 divided by 2. And if you take the natural logarithm of both sides, x times ln 3 divided by 2 will be ln 1 plus square root of 5 divided by 2. And x can be found as ln 1 plus square root of 5 divided by 2 ln 3 divided by 2. Of course, if you want, you can use this property related to logarithms. If you are dividing the logarithm, the x inside the logarithm function, then this can be written as ln 3 minus ln 2. You can also rewrite the last expression or solution to this equation in terms of these expressions. So thank you very much for listening to the solution method I have mentioned, and see you during the next question solution. Take care.